Hello, everybody. So, have you joined the last class, guys? So, how many students are there? Sanjana, can you tell me? Okay. Yeah, right. That's the thing. Yeah, that's the thing actually I'm worried about. But anyway, so what I was suggesting actually, one person just joined a few minutes back. So what we can do, the class time will be there, right? From 7 to 9. But but with this few number of like one, two people are joining. So what we can do, we can make a group, or I can share my number to you so that you can directly contact me in case you will find any doubt, or you can directly mail me, right? So that we can discuss on that. And regarding class, I will definitely put the video because it's a matter of requirement for me. To complete my syllabus. Okay, anyway, I think it's a matter of four class. So let's start with the today's class. Hopefully, it will be okay. So yeah, so let's start and let's see what we can do. I think you have already discussed the same questions last class also, right? That I'm supposed to discuss. So let me discuss with you. Okay. In case you'll find any doubt, you can tell me. Or apart from this, you can ask me any question on bioelectrochemistry. Before that, I would like to just know you guys. So, can you just introduce yourself? Because two people, if it is strength is more, then I would not have asked. Okay. S- So, okay. So you are currently doing your. Oh, nice, nice. So you are, I think, much more expertise in this particular field than us as well. Anjana, are you there? Yeah. So can you introduce yourself? Okay. So you both are from same college? Oh, nice. Good, good. Okay, so just let me discuss what I have for you, and you can correct me if I'm wrong, and we can discuss on that. And this will not be a class, but rather you can say you can think it as a discussion session. Okay, so I think the NPTEL has organized this in a way that it is a 2 hour class, so which is I think will be very much to discuss 10 questions. But apart from that, I will try to reach some concepts, and since class strength is less, so I will rather suggest you to involve directly, and you can just uh, uh, you can just directly make yourself involved in the discussion. Okay, no need to shy or no need to hesitate. So we can just discuss like that. Okay, so let me share my screen. So you have already read electrochemistry in your college. Okay, okay, good. Okay, hi Santhia, are you there? Okay, so let's start with today's session. Is my screen is visible to you guys? Yeah. Okay, so this is myself, Nitesh Kumar Port. I'm working as a PMR fellow in Department of Biotechnology, IIT Hyderabad, and I'm basically working on. Uh, I think if you can see my background, where mainly on molecular biology lab we have, and we are dealing with yeast biology and cell biology stuffs, but yeah, I have got this course as a bioelectrochemistry. My specialization was biochemistry during my master's, so hopefully I'll be able to guide you on this note. So this was your question. First question, that pH of an acidic solution is what? So yeah, below 7, right? Now just tell me how you understand pH. What is pH? Tell me, guys. Tell me. Just let me discuss and let yourself make yourself free to discuss. Let's talk. Okay. Just one to one, because three people are there. Just think like I am one of your teacher in your college, and we can just discuss and like since you are two, like what is pH? So if I'll tell, then the pH is basically negative logarithm of hydrogen ions, right? That is minus log H plus ions. So the more is the pH, okay, the more is the pH, that means the solution is, since it is a negative logarithm, okay. So like as I shown you, okay, just don't make yourself confused, okay. Okay, as I have shown you, this is the pH scale, okay. So 7 is your neutral pH, and the more is the pH, the solution is alkaline, okay. And the less is the pH, the solution is called acidic. Now why it is so? Because see, the pH is basically negative logarithm of your H plus ion, right? So negative, the minus log H plus. Suppose for example, let's take the H plus concentration is around 10 to the power 5. Okay. Now, okay. So let's take the H plus ion concentration of 10 to the power 5. Then what will be the pH? 10 to the power minus 5, for example. Then the pH will be 5, right? Similarly, suppose the concentration is 10 to the power more, that is 10 to the power minus 14, 10 to the power minus 13, minus 12. So more the negative number it is, the pH will be more positive. Okay, so more the H plus ion, the solution is more acidic. Okay, and similarly, if the pH is 7, it is neutral. If the pH is less than 7, it is acidic. More than 7, it is basic. However, there is one more term called POH. Okay, now what is POH? Okay, POH basically calculates the negative logarithm of your OH minus I. For example, for a compound or for a solution, if the pH is 3, then what will be the POH? Any of you? Okay, just let me tell you that pH plus POH is equal to 14, because as you see here, the entire scale, logarithmic scale, that is, yeah. So as we are seeing here, the total scale is 14, right? So pH plus POH is equal to 14. So if the pH is 3, then the POH is 11. If the pH is 11, then the POH will be 3. That is basically pH plus POH is equal to 14. That is PW. And PW is basically a pH of H plus ion plus pH of OH minus 1. That is basically the pH of water. Not pH, but that is basically KW. That is basically water. Based on the water constant, it is calculated that H plus and OH minus ion in total comprises the number 14, and based on that, if pH is whatever is the pH, 14 minus pH is equal to your POH. Okay. Now this is one. I think basically there are three concepts that uh, are present in your entire lectures here. So the second question is that for a material, oxidation occurs when? Okay, when oxidation occurs, when reduction occurs. So the main purpose of this question is to make you familiar. What is oxidation? What is reduction? What is oxidizing agent? What is reducing agent? When it is called to be oxidized or when a cell is called to be reduced. Okay. So if you see in this figure, let's take A. Okay. So A is double negatively charged. A is double negatively charged. Okay. Now A is lost. If you read the statement 1, when the reactant loses electrons during a reaction, it is called oxidation. Okay. So when A minus or A2 minus releases its electron one by one, it will be called oxidized. Okay. If you see the A in the left side and A in the right side, in the left side the A have two negative charge. In the right side the A have no negative charge. In the meanwhile, in the journey, A loses its electrons. And that process is called your oxidation. Okay. And the compound it forms after oxidation is called oxidized. Okay. Now, what makes this oxidation happen? Okay, what makes this oxidation happen? For example, when A converted to A, sorry, A minus converted to A, electron was taken by some other compound, right? And that compound is called your oxidizing agent. Here, B is your oxidizing agent. Okay, so let's take the reaction again. That A with two negatively charged ions converted to A and it loses two electrons. Okay, and that two electrons is taken by B to form B double minus. Okay, so basically A reduces, sorry, A oxidizes to A minus oxidizes to A as it loses electrons, and the process is regulated by B because that electrons is taken by B to form B2 minus. Okay, so B is reduced when a reactant accumulates electrons during a reaction. It is called reduction. And when a reactant loses electrons, if you see here, when a reactant accumulates electrons, when it will convert it to negatively charged, it gain electrons. That then during that reaction, it is called reduction. And when it loses electrons, it is called oxidation. Okay. So based on this concept, your question number 2 is that for a material, oxidation occurs when it, what will be the answer? Yeah, when it donates electron, right? And when it acts, reduction occur. And what makes reduction happen? It is called oxidizing agent. What makes oxidation happen is called reducing agent. Okay. Sorry. What make oxidation happen? It called your oxidizing agent. What makes reduction happen is called your reducing agent. Okay. Now, based on that, the third question is that the element A in the reaction A plus E minus is converted to A minus. So where what happened here? Here A is basically taken one electron to form A minus. So basically this is oxidized or reduced. It is reduced because it engulfs the electron. When it loses electron, suppose A minus converted to A, then it is oxidation. When A is gaining electrons, it is called reduced. Okay. Now, who is the following is true? Oxidizing agent get oxidized in the reaction. Reducing agents accept electrons, oxidizing agent donates electron, and reducing agent gets oxidized. So if we will take first option, oxidizing agent gets oxidized in the reaction. Let's see. So oxidizing agent, what is here oxidizing agent? It is B, right? So the option is that oxidizing agent gets oxidized. But what is happening to B? oxidizing agent is getting reduced because it reduces, because it gains the electron that is released by A. Okay, so in the process of oxidation, the electron that is released is basically gained by the oxidizing agent. So it reduces, it does not oxidize. Okay, now the reducing agent accepts electron. So the reducing agent is here, and it does not accept electron, rather it loses electron. Okay, because it is the reducing agent, it forms reduction. Okay, so in order to gain electrons, the electrons loses by the reducing agent will be gained by the molecule that is basically forming reduction, that is most basically undergoing reduction. Okay, so the third option is that oxidizing agent donates electron. Again, you can see this, that oxidizing agent does not donate electrons, rather it receives electron. Okay, so I think last option is that reducing agent gets oxidized. So you can see basically reducing agent is get oxidized. So that is what your answer will be, that reducing agent will get oxidized. Okay, now this equation is there for you, that which of this is not true. So these are the basically from Faraday's first law, and if you see here, the equation is del G naught is equal to minus NF E naught. So this is basically Faraday's first law, and F is equal to 96485 coulomb per mole of electrons. Now if you see the heat, that is Q is equal to N into F, N is the number of mole of electrons, W is equal to EQ, that is work is equal to charge into uh, energy of the electron, but voltage, this is most probably voltage. But now if you see this reaction, del G naught is equal to minus NF E naught. Now NF is equal to your Q, so del G is equal to minus Q E naught. Now if you see all the reactions, W is equal to EQ, this equation is there. Okay, now del G is equal to minus QE, del G is equal to minus NF is equal to Q, so this will be QE. E is equal to IR, basically electricity is equal to, current is equal to voltage is equal to current into resistance, so is equal to IR. So the first equation, that is N is equal to QF, it is basically Q is equal to NF, that is charge is equal to number of mole of electrons into Farad. So this equation will be Q is equal to NF. So this one is your wrong, not true. Rather, the rest three are basically from the Faraday's first law that you can see in this slide. Okay, so in galvanic cell, the depth of chemical process is converted to electrical energy. So if you can, if you are aware about this reaction, here you can see there are two things. One is your cathode and one is your anode. So anode का क्या काम होता है? Anode is basically it is positively charged, right? No, it is negatively charged. Okay, anode is negatively charged and it takes cations towards it. Cathode is basically because it attracts the cations. Okay, so cathode is basically negatively charged or positively charged. Hello, are you all sleeping? So guys, see, two things are there. Okay, yeah, tell me. So in a galvanic cell, what happens? You can see here there are two. See, Zn is also positively charged, copper is also positively charged. But based on the table, if you see, there is a table based on which one is comparatively negative and one is comparatively positive. Okay, so here if you see, so copper will be act as a cathode. Okay, that is copper is negatively charged and this is your cathode, and the cathode is basically attracts the cation. Okay, and this is anode that basically attracts the anions, that means this is positively charged. Now what happens when ions get flows, like here zinc, that is Zn2 plus, that released from this electrode, it basically travel, right? So if Zn will move in this way, then electron will flow in this way, that is shown in uh, left to right. Okay, so electron will move from anode to cathode and current will flow from cathode to anode. Okay, so what basically forming the energy here? Here basically in this process we are getting electrons, right? That is, we are getting electric energy. Now, what basically making this electric energy? This is only the free energy that is because of the release of these ions. Okay, in this solution or in this cell is responsible for making the chemical energy. Yeah, this is electrical energy. So it is the in the galvanic cell what happened? Yeah, in the galvanic cell the free energies, that is because of the result of ions or because of the formation of ions. Like if Zn will break down, it will find Zn plus SO4 minus. If copper will CuSO4 will broken down and will find Cu2 plus SO4 minus. So the movement of these charges will basically leads to your transfer of or generation of electricity. Okay. So based on this only, there are one more questions. In an electrochemical cell, that is galvanic cell, oxidation means what? A loss of electron, right? So if you will see here, where the loss of electron is happening, tell me. Yes. So that is the thing, that in the anode side, the loss of electron is happening, and that electron will basically, yeah, because and that is making it Zn2 plus, and that is basically taken by the Cu2 plus to form Cu. Okay. So, uh, so the oxidation occurs at anode, and your reduction basically occurs at your cathode. Okay. Yeah. As this electron will moves, it is basically form the it will basically bind with the Cu2 plus, or and it will form the molecule. So basically electron is engulfed here and released from here. That is released from the anode and get moved towards the cathode. Okay. Now this is one of your equation. The calculate the voltage produced of the following reaction. That is X leads to X plus 10.36 E minus del G is equal to 10,000 kilojoule. Now you have the number of electrons released. You have del G, and now we have to calculate the voltage. Okay. So tell me, how can we calculate the voltage? You have discussed in the last class. So you try and let me know, else I will first in the next class I will first discuss this problem, because we have not gone through the details formula yet. I will give you a basic introduction to that, and I will discuss this formula in the next class. Okay. And uh, I think you have discussed in the previous class as well, so I expect you guys to also contribute. But see, this is not a big problem, because you have del G, you have number of electrons. Okay, so this is basically Faraday's first law equation. So you have N, you have del G. What you need to calculate? You have to calculate V. So basically, you need to find out the formula. Then which formula will be perfect for this particular question. Okay, so this is a this we will discuss in the next class. Okay. Now the reaction described in question 8 is what? Now question 8 जो है, in this question you will find X lead to X plus 10.36 electrons. Del G is equal to 1000 kilojoule. Now if you are aware about that, del G जहाँ पे positive होता है, when del G is positive, the reaction is non-spontaneous. Keep things in mind. If del G is positive, then the reaction is non-spontaneous. And if the del G is negative, then the reaction will be spontaneous. So since here del G is equal to 1000 kilojoules, so del G is very much positive. So the reaction will be non-spontaneous. Okay. Now, which of this is not present in Daniell cells? So this galvanic cells is also called Daniell cells because of the two scientists that they have discovered. One is your Voltas and one is your Daniell. So they have discovered this particular cell, and based on that, it is named as galvanic cell. And if you'll find, we have copper, we have zinc. These two act as an electrode in your cell. We have copper sulfate that is basically act as a buffer to generate electricity, and we don't have anywhere hydrochloric acid here. Okay, so we have one more pipe here. You can see the porous disc. This is basically to maintain the salinity of the buffer, and here some chemicals are used, some buffer are used to maintain the flow of ions. Okay, but we don't have hydrochloric acid involved here. Okay, in the Daniell's case. So this is what the questions of this week, which are very simple questions, except one or two questions. These are a few questions that you should be aware of being a student of electrochemistry. And we can discuss one more thing, the del G concept, that what basically del G is. That is, del G is equal to your Gibbs free energy. And the del G defines whether the reaction will be spontaneous or non-spontaneous. Okay. Del G can be calculated by a various formula. There is even one more formula, that is del G is equal to del S minus T del S. So del S is your formation enthalpy of formation. Del S is equal, del S is your spontaneity of the reaction. So basically, del G defines whether the reaction is spontaneous or non-spontaneous. Now, what is a spontaneous reaction? If the reaction is spontaneous, then you don't need any external force to run that reaction. It will run smoothly. But when a reaction is non-spontaneous, then you need to provide it some energy to make it spontaneous so that the reaction will go smoothly. So spontaneous is very smoothly running experiments or reactions in which the free energy is very much less. That is Gibbs free energy. That is del G is in negative. If del G is in negative, the reaction is spontaneous. And if del G is positive, then the reaction will be non-spontaneous. Okay. Uh, Anything you would like to discuss from your class? Okay, guys, I'll put the video in a better way, and we'll discuss from the next class and bit more details. And so I think you have already discussed in the previous classes as well, and you have a 2 hours class, so we can better to discuss some concepts from the next class. Okay, so hopefully my class will be on Monday for next 3 weeks, and it was nice to be with you for this 40 minutes. And I would have taken much longer, but I don't think that you guys have any doubt. Do you like to ask anything regarding electrochemistry, purpose of electrochemistry, or anything that you would like to suggest? Are you online? Are you there? Yeah, tell me. Hi, how are you? कहाँ से हो आप? Okay, tell me. Okay, so see, bioelectrochemistry जो होता है, bioelectrochemistry जो है, when it is used, it is basically a principle. Okay, so अगर तुम फ्यूचर स्कोप के बारे में सोच रहे हो, तो basically you can join research like us. You can join research. You can join any chemistry lab. You can join any biochemistry lab. Okay, and on that you can work on the principle. This is basically not pure biology. So bioelectrochemistry, why we are calling it as a bioelectrochemistry? Okay, so you want to know the scope of electrochemistry or bioelectrochemistry? Yeah, see, electrochemistry is a purely chemistry concept, right? So in there, you can just you will work on the process of engineering things like how to maintain the flow, how we can generate more voltage, how you can make the cell more efficient in order to work. But in bioelectrochemistry, we are dealing with the electrochemical aspect that is present in biological sciences. Okay, now for example, we have a system, we have a cell. Okay, now in a cell, you will find there are different buffer systems. We have sodium ion, we have potassium ion, and the movement of that is basically responsible for generation of electrons and protons. Okay, and that will basically responsible for maintaining charges. If you study your entire neurochemistry, if you study your entire signal transduction, you will find in many where that it is the ions that results in the process of generation of charge. Even what we today discussed, it is basically pure electrochemistry. Okay, this is basically basics of your electrochemistry. Now I am putting you one concept. Okay, suppose there is suppose you have glucose. Okay, now what is the condition that glucose will convert it to energy in our body? Are you getting my concept? What I am telling, I get sugar, I am taking glucose. Now, if I am taking glucose, it might not convert it to the energy that I want. It might create some other things, right? It might create lactic acid. It might goes in a fermentation pathway. Now, basically, देखो, I'm just putting one basic discussion, okay? So, if you are aware of this, glucose, I am taking one molecule, that is your glucose. Now, there are several pathways. Glucose form energy in our body that is worked as an instant energy. Okay. Second thing, glucose level is controlled by your insulins. Okay. Third thing, glucose forms and stores in the liver by the process called glyconeogenesis. Now see the concept. We have glycogenesis. We have glyconeogenesis when we have shortage of glucose, the other molecules in the body form glucoses. Okay, we have glycolysis to form energy. So the same glucose molecule at different circumstances, at different conditions and different systems have different biological roles and different uh, output or different outcomes. So what is the factor that defines whether glucose will go to the liver, glucose will go to the blood systems, or whether glucose will go to the brain? What is the factor that will decide? So this is basically depends on your value of different biological constants, electrochemical constants. For example, rate of forward reactions, rate of backward reactions, electrochemical constant, your del G. Suppose in a reaction, suppose glucose to energy formation reaction, if del G is very less, then the reaction will spontaneously occur. If del G is more, then the reaction will not occur. So these are some factors that defines, and based on that, you will be able to know whether the reaction will should occur or not. For another one more interaction, I will just put forward you that suppose we have the enzyme. This is a catalytic side act, okay, and we have a protein that basically interact with this. Now, what is the condition that it will react? It is not that the reaction is random, right? So these are the factors that del G value. If the del G of this reaction is less, then the reaction is spontaneous. That is, this is a smooth reaction. It will go automatically occur. If del G is very high of this reaction, that means the reaction is not normal. But at condition with the presence of effectors, with the presence of some external molecules, with presence of some external conditions, environment, the reaction can be carry forward. Clear? And this is basically we study to deal with the study of enzyme kinetics to understand the drugs designing, how the interactions are occur inside the cell level, what reaction is favorable for the body, What reactions are unfavorable for the body? These are the few questions or few biological questions. If you want to address, then you need to calculate this K on K of diffusion constant and all these things. That is basically your aspects of bioelectrochemistry. Clear? Yeah. So this is a major you will find it very useful rather. At least there are few concepts in this lecture. The major concept is your about del G. If you do one thing, since you guys are there, just do one thing. Go and write it down every formula that is associated with del G now. Okay, and make a word file and practice this at least two questions from everything. That will definitely help you to create good exams and definitely help you to improve your knowledge in the field of electrochemistry, because electrochemistry and bioelectrochemistry is a major problematic topic. So you have to understand the formula, you have to understand the concept, and you have to apply it by practicing the questions. Okay, and in case you find any doubt, you can just message me. Okay, you can just message me on my WhatsApp number so that I can get back to you at any point of time apart from the classes. I'll just share my number here. Okay. So you guys can just get back to me on this. And the class time is very less, so it is really demotivating for me to take classes. But anyway, I have to do my duty. So, but anyway, thank you, both of you and all of who have joined and part of this classes for well. And we'll get back to on next weekend. That is then next Monday. Okay. So you can just get back to on my number so that I'll try to, or you can just mail me on my mail ID. That is, so you can just get back to me on this my contacts. That is my mail ID and my phone number, WhatsApp number. If you find any doubt, you can just find me anytime. Okay. So feel free to contact if you find any doubt. And I hope this class is bit interactive for you and will helpful for your future endeavor. So thank you all, and we'll be in touch. And you can just put a message or put a mail to get back to get me there. Okay, and you go read. Make a list of all the formulas associated with Delgy, practice questions, and get back to me in case you find any problems. I'll get back. I will definitely try to get back to you whenever I'm free. Okay. Thank you guys. That's it for today's class. Okay.